Welcome back. We're going to talk now about rotating around a different axis. The first two, the disk and the washer, had been around the x-axis, but what if we're rotating around something completely different? And for this example, we have chosen x equals 4. So let's start by sketching our disk. There it is. Notice that it has a height of delta y and it has a radius, since this is some point x, a radius of 4 minus x. So what's the volume of our disk? Well, the volume of our disk is pi times 4 minus x all squared delta y. The delta y tells us we're going to integrate with respect to y. We're going to be stacking these up and down instead of side to side. So we're going to want this equation to be in terms of y. A little algebra tells us that x is equal to 4 times y over 3 squared, which means that the volume of one disk is pi times 4 minus 4 y over 3 squared, all squared delta y. Couple things we could do to make this simpler, just looking ahead. We see that this is 4 times 1 minus y over 3 squared delta y. So I'm going to take that 4 and I'm going to put it out here, but it will be a 16 because it's actually 4 squared. And I'm also going to then square this 1 minus y over 3 squared. So what I get is 16 pi times 1 minus, well, y over 3 squared is 1/9 y squared. So I actually have 2/9 y squared when I multiply the binomial plus 1/81 y to the 4th. And just for fun, I'm going to factor out a 1/81 because then I'll have a nice non-fractional polynomial to find the antiderivative of. So I've got 16 pi over 81. This will become an 81. This becomes 2 times 9, 2 times 81 over 9, 2 times 9, which is 18y squared. And this just becomes a y to the 4th delta y. And now we've got a fairly straightforward derivation. And the only other thing we need to know, since we're integrating vertically, is we start at 0 and we're going to come up to here. Well, since x is 4, y must be equal to 3. So we have volume equals the integral from 0 to 3. You know what? I'm going to erase that and put my 16 pi over 81 so that I don't forget it. By the way, I didn't mean to switch to green. I switched to green to draw the picture and forgot to switch back, in case you're wondering, geez, why is he writing in green this time? But there it is, plus y to the 4th dy. All right, so switching pages to find the antiderivative. We know that, you know what, I want to switch back to black because I like black better for drawing. The volume is 16 pi over 81 times. Well, this is 81y minus, well, 18 over 3, which is 6y cubed, plus 1/5 y to the 5th. Again, generally good idea. Double check yourself by just in your head quickly take the derivative. Derivative of 81y, 81. Derivative of 6y cubed is bring down the 3, 18y squared. Derivative of 1/5 y to the 5th, bring down the 5, 1 y to the 4th. Good. It's always worth doing that quick check in your head. Integrated from 0 to 3. And I'm not going to plug in the 0. Well, we don't have to plug in the 0, but I'm not going to plug in the 3 and go through all the math. What I end up with is 128 pi over 5 units cubed. And if we didn't need an exact answer, this of course is an exact answer. It has the advantage of being exact to as many decimal places as you need. There are times when you need a lot of decimal places, or I could shove it into my calculator and using my numerical integration feature, I would come up with 80.425 cubic units. It's also a good way to check your answer. Plug 128 pi over 5 into your calculator, plug 80.4, plug the numeric integration in, see if they come up the same. All right, so my students, go ahead and do exercise 21 in the book. And again, what we talked about here is we talked about a situation where we were stacking disks vertically by integrating with respect to y, and the fact that we were not rotating around the x-axis, which means we had some radius that was actually a function of x. Okay, and we'll be back to talk about something called shells in our next video. Thanks for watching. Hope you learned something.